Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our actuarial students, please go to smarturl.it/help-ISU-actuary. And there are also other websites that I give you links to here that show you various resources that I offer to help you study for actuarial exams. My advice on how to pass actuarial exams is at smarturl.it/pass. Here's the problem for today. George and Paul play a betting game. Each chooses an integer from 1 to 20, inclusive, at random. If the two numbers differ by more than 3, George wins the bet, otherwise Paul wins the bet. Calculate the probability that Paul wins the bet. So the important thing to notice here that we have is that we have a discrete uniform distribution on the integers from 1 to 20 for the choice of a number for each of them. And we are basically trying to find the probability of them picking two numbers that differ by no more than 3. And here is the solution. Let G be the number that George chooses and let P be the number Paul chooses. Both G and P are discrete random variables with uniform distribution on the set of integers from 1 to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The probability that Paul wins is probability that G minus P absolute value of the difference is less than or equal to 3. And there are 400 possible pairs of numbers that can be values of G and P, the random vector GP. We will now figure out the number of pairs of values of GP that satisfy the condition that probability of absolute value of difference of G minus P is less than or equal to 3. Well, if G is equal to 1, then P can be 1, 2, 3, or 4 to meet the condition, for a total of 4 favorable outcomes. If G is 2, then P can be 1, 2, 3, 4, or 5 for a total of 5 favorable outcomes. If G is equal to 3, then there are 6 favorable outcomes. For G equal to 4, through G equal to 17, there are 7 favorable outcomes. Basically, 3 to the left, 3 to the right, and the same number as the one that we're looking at. For G equal to 18, 19, and 20, the counts of favorable outcomes are 6, 5, and 4 respectively, just like at the other end for 1, 2, and 3. The total number of favorable outcomes is therefore 4 plus 5 plus 6 plus 14 times 7 plus 6 plus 5 times 4, so it's 128. And the probability we're looking for is equal to the ratio of the number of favorable outcomes and the total number of possible outcomes, so 128 over 400, which is 0.32, and that's answer B. Please remember this is copyrighted material. Problem originally comes from the Society of Actuaries and belongs to the Society of Actuaries. It is reproduced with permission, but the solution is mine. Good luck in your studies and good luck on the test.